Hello, my name is Rob Lindeman from the HIT Lab New Zealand at the University of Canterbury, and I'm going to be talking to you today about some work we're doing on helping people move around comfortably in virtual reality. This work was mainly carried out by my rockstar master's student Yue Zhao, and also in collaboration with my colleague Piumsomboon. So if we think about moving around in VR, physical walking has been shown to be the best. But the problem is we're limited to the physical space that we're in if we physically walk around, while VR might be relatively unlimited. We're also focusing more on medium distance travel, basically to places that you can see, but that might be too tiring to actually walk to physically. So the approaches that have been done in the past rely on some form of scaled walking. And the two main approaches that have been explored are ground level scaling and 7-league boots. And what we're trying to do is to strike a balance between the best aspects, so using the best aspects of both natural walking and these other techniques, while trying to avoid some of the downsides. So if we think about these three approaches, ground level scaling basically makes you into a giant. So everything is scaled up, in this case, twice the size. While 7-league boots keeps you the same size, but lets you take really long strides. With daddy long legs, we strike a balance here by keeping the torso the same length, but stretching the legs. And through a pilot study, we determined that kind of 5/3 of the user's height is a comfortable length. And some of the strengths that we found is keeping the interpupillary distance and the distance to the ground to be better for the user in terms of interacting with objects and viewing the environment in a realistic way. So we ran a user study comparing these three techniques, and the main research questions that we looked at covered things like walking behavior, physiological measures of like comfort, and also user preferences in terms of the three techniques. The physical space that we used was a 4x4 meter physical area, and the hardware was the HTC Vive Pro and controllers, with additional trackers on each of the feet and at the small of the back. The procedure that we went through is we started the participants walking in VR with no alteration, so no gain, and we call this natural walking. Then we exposed each of the participants to all three of the methods, so it's a within subjects design. And we randomized the order that they were exposed to ground level scaling, 7-league boots, and daddy long legs. And then we collected questionnaire data in between and around during each of the breaks. We had them perform what's called an activate and follow task through an environment that was like a park, there were lots of visual elements throughout the park to give them some visual cues and some visual flow. And they had to walk through several segments on each route. Some of them were straight and some were curved. And the number of turns and straights were kept the same for each of the routes, even though the routes themselves were different. So the participants started by walking to this blue dot, and then the dot would turn yellow, and they would be shown a path to follow to another blue dot, and then once they got to the blue dot, it would turn yellow and the next segment would appear. And at the bottom here, you can see kind of 5 different segments of one route that they would start at the yellow dot. They would move here, and then from here they would move here, and then from here they would do this. And you notice that there is, for example, this is an S-shaped segment, and every route that they took had an S-shaped segment, though it could have been rotated or mirrored in some way. We used standard questionnaires to collect subjective measures. We captured all the tracker data as well to do some performance and showing the different routes. And then we interviewed them to gather qualitative feedback. we categorize turns, straights, and approaching as three behavioral aspects of the route. So these are defined in the paper in much more detail, and we use these in all of our analysis. But as an example, if you look at the turn started kind of halfway through a cell segment and continued on through the turn until they were about another half a cell segment, half a cell length from the turn. And so this we used as the turning area in our analysis. And the same was true as we defined straight walking and approaching in similar ways. So the three methods were most similar for walking straight. So there's again much more detail in the paper. The gold line here is what we call is the natural walking mean for speed. So DLL was closest to natural walking with 4 times and 6 times gain. So any technique should be closest to this gold line. Above or below doesn't really matter. The main thing is how close they are to the line. So some made smaller steps using daddy long legs, which was more like 7-league boots, and some made bigger steps using ground level scaling. So participants took longer steps using ground level scaling, and some mentioned they felt like they were a giant, so that they should take larger physical steps, but we're not sure if this is the reason. Another interesting thing to look at is the walking behavior around the turns. So we can see differences when we look at this walking behavior. So the turning paths, for example, were different for each of the methods. If we look at the ground level scaling, they really had a smooth turn, very much like the natural walking approach. So we can see both in all of the gains, there's this behavior is kind of a very smooth turn. Whereas if we look at 7-league boots, the turns were much more like 2 90-degree turns to go around. Whereas the daddy long legs had kind of a 120 to 140 degree smooth turn, but it was like here's a turn and then here's a turn, as opposed to the smooth turns that ground level scaling had. So we can see these different behaviors. And similarly for the straight routes, there are slightly different behaviors in the motions. I'm not going to go into detail on the questionnaire data. There's lots and lots of details in the paper. You can see some of the statistical differences listed here. Some of the qualitative feedback that we got from the semi-structured interviews are listed here. So if the color is, for this visualization, if the color is stronger, so like a darker background, that means more people said this. So if we look at ground level scaling, words like comfort and easy were mentioned a lot. For 7-league boots, effective was mentioned several times. For daddy long legs, several people said the acceleration didn't feel as fast as 7-league boots, so it felt easier to control, enjoyable, comfortable. Some of the downsides for ground level scaling is that it was a little bit restricted. People were afraid to bump into things. 7-league boots, people felt that it was difficult to walk straight and that the acceleration was very fast. And similarly with daddy long legs, people didn't always feel totally in control. So as a final discussion, we can revisit the research questions. We can see that in all cases, ground level scaling was superior to daddy long legs, which was generally superior to 7-league boots. And so we can think that the technique could be, the optimal technique could be based on different aspects. So for example, ground level scaling seems to be really good if it's in an outdoor or open environment. Whereas if you can't be a giant, daddy long legs might be the preferred approach. So the key contributions for this work are that we introduced a new locomotion technique that tries to combine good aspects of existing techniques. We compared them across a lot of different measures, and the user study showed that the daddy long legs outperformed 7-league boots in all aspects, but that ground level scaling outperformed all of the other approaches as well. So thank you very much.